I'm Shraddha. I'm from CSC department. Uh, my Tech Talk topic is incidents and adjacent matrices in graph theory. If we have to learn about incidents and adjacent matrices, first we have to learn what is graph theory. Graph theory is a branch of mathematics that studies graphs, which are structures made up of vertices and edges. It is widely used in computer science, biology, and social sciences, and many other fields. Wait, let me put on timer. Achuna feelings, achuna feelings, One, two, three. Go to that. Respected ma'am, sir, myself Shraddha. I'm from CSC department. My Tech Talk topic is incidents and I'm Shraddha from CSC department. Uh, Today my Tech Talk topic is incidents and adjacency matrices in graph theory. So firstly, if we have to know what is incidence and adjacency matrices in graph theory, we need to have a basic idea about what is graph theory. So, introduction to graph theory. Graph theory is a branch of mathematics that studies graph, which are structures made up of vertices and edges. It is widely used in computer science, biology, and social sciences, and many other fields. Understanding graph is essential for analyzing complex networks and relationships. Basically, graph theory is a branch of mathematics. Basically, it is mathematics, but it is used to study graph. A graph in graph theory consists of vertices and edges. Vertices are the points, and edges are the connections between two vertices. So that is the basic idea of graph theory. So if we have to know what is incidence and adjacency matrices, here are some few definitions that we have to know before learning what are the incidence and adjacency matrices. So a graph consists of a set of vertices and edges between them. Between vertices are also called as nodes, and edges are also called as connections, as it connects two nodes or vertices. So graphs are basically are of different types, in which few types are directed graphs, undirected graphs, and weighted graphs. Directed graphs have edges with direction. Undirected graphs have edges without direction. Weighted graphs assign a value to each edge, represent cost, distances, and capacities. Directed graphs have edges with direction. It means that the edges between two vertices have a particular direction of the edge. Whereas in undirected graphs, the edges do not have any direction. In weighted graphs, the edge have a particular value. This value represents either cost, distances, or capacities. So why do we have to use matrices in graph theory? So matrices provide a compact, efficient way to represent graphs mathematically. They facilitate various graph operations such as traversal, pathfinding, and connectivity analysis. Two main types of matrices are commonly used in graph theory, which are adjacency matrices and incidence matrices. So in this matrices provide an efficient way to represent graphs, which gives us an idea about traversal, pathfinding, and connectivity analysis. This graph theory is mainly used in mapping, which helps us to understand better about the routes and maps. So to make this complex thing into a simple format, we use matrices in graph theory, as it helps us to understand better. So what is adjacency matrices? Adjacency matrix is a square matrix used to represent a graph. Basically this adjacency matrix consists of only ones and zeros. So if for example, let us take a graph where it has only 3 vertices. So the order of the adjacency matrix is basically 3 by 3. Each element of the matrix indicates whether the pairs of vertices are adjacent or not. So basically, if the element in the matrix is 1, then there is a connection between those two vertices and they are adjacent. So this adjacency matrix basically gives us an idea about if the vertices are adjacent or connected or not. For an undirected graph, the adjacency matrix is symmetric, which is basically if the matrix, let us take the adjacency matrix as A. So if it is symmetric, then it has to undergo then it has to uh, uh, prove the statement as A should be equal to A inverse. For a directed graph, it is not necessarily symmetric. It can be symmetric or asymmetric. So structure of adjacency matrix, as I've previously mentioned, that the rows and columns of the matrix correspond to the vertices in the graph. If there are 3 vertices or 4 vertices in a graph, then the rows and columns would be 4 by 4 or 3 by 3 for 3 vertices and 4 vertices respectively. A value of 1 indicates the presence of an edge between two vertices. The value of 0 indicates there is no direction exists between two vertices because there is no connection between them. So that was the example of adjacency matrix. Applications of adjacency matrix. Adjacency matrix are used in algorithms for searching and traversing graphs such as depth first search. They help in determining the connectivity between paths within a graph. Additionally, they aid in analyzing network flows and optimizing routes in transportation problems. So these adjacency matrix are used in mapping, which optimizes routes in transportation problems and solves the uh, complex problems in routing and mapping. This adjacency matrix are used in algorithms such as depth first search. This is basically an algorithm for searching and traversing graphs. This also helps in determining the connectivity and paths within a graph. As we have learned about adjacency matrix, now we'll see what is an incidence matrix. An incidence matrix is a matrix that represents a relationship between vertices and edges in a graph. Basically, incidence matrix and adjacency matrix both work on the same principle of telling the relationship between vertices and edges, but here as we have previously learned, adjacency matrix is like if there are 4 vertices, we used to take the order of adjacency matrix as 4 by 4. But in here, in incidence matrix, we take row correspond to a vertex and column correspond to edge. So, for example, if we have 3 vertices and 2 edges connecting 3 vertices, so the order of the matrix will be 3 by 2. The entries indicate whether the vertex is adjacent to an edge, often represented by 1 or 0. Yeah. Structure of incidence matrix. In an undirected graph, a vertex incident to an edge is marked with A, while others are marked with 0. In a directed graph, the entry can be marked differently for incoming and outgoing edges. This structure allows for a clear visualization of vertex-edge relationships. This basically gives a clear idea about how a vertex or how an edge is connected between two vertices. So, in undirected graph, when a vertex is incident to an edge, the entry is taken as 1. While if there is no connection or the edge is not connected to the vertex, it is taken as 0. So, for example, for a graph with vertices A, B and C and edges E1, E2, E1 and E2, just as the same example that I have given previously. This is the example. Applications of incidence matrices. Incidence matrices are helpful in network flow problems and studying bipartite graphs. Bipartite graphs is one of the type of graphs. So they are used in algorithms for computing graph properties like matching and covering. Additionally, they facilitate the representation of hypergraphs which involve more complex relationships. So incidence, as previously we have discussed about adjacency matrices, incidence matrices are also helpful in network flow problems as studying bipartite graphs. They are used in algorithm for computing graph properties like matching and covering. For a clear idea, we compare adjacency matrices and incidence matrices. Adjacency matrices provide a direct view of vertex to vertex relationship, while incidence matrix focuses on vertex and edge relationship. The adjacency matrix is more compact for dense graphs, while incidence matrix can be more efficient for sparse graphs. Each matrix has its own advantages depending on the graph structure and problem being analyzed. So, here adjacency matrix gives a clear idea about vertices and vertices connections, while incidence matrix gives us an idea about vertex and edge relationships. Each matrix has its own advantages depending upon the graph structure and problem being analyzed. Every matrix has its uniqueness and has a different approach of being the problem solved. Limitations of matrix representation. Even though we have many advantages, with that we have limitations also. Both adjacency and incidence matrices can become large and unwieldy for large graphs. They may or may not capture all graphs properties effectively, such as weights and multiple edges. Alternate representations such as adjacency list may be more efficient in such scenarios. To conclude, incidence and adjacency matrices are fundamental tools in graph theory for representing and analyzing graphs. Their applications span various fields including computer science, transportation, and social network analysis. Understanding these matrices enhance our abilities to work with complex graph structures efficiently. So this is my basic idea. This is my idea on incidence and adjacency matrices in graph theory.